everybody. It's Miss Amy at the Grass Valley Library. Thank you so much for joining me for another episode of Random Acts of Science. This week, during our summer reading program, we are focusing on the country of Japan. Japan is in the Pacific Ocean, and that's a very active area of the world for earthquakes. In fact, 90% of the earthquakes on the planet happen in the Pacific Rim, or the Pacific Rim of Fire as it's called. So we are going to talk a little bit about earthquakes today, and then we're going to build a seismograph, which is what seismologists, who are people who study earthquakes, use to measure the size or magnitude of an earthquake. So we're going to build a very simple seismograph, but first let's talk about earthquakes and what causes them. All around the surface of the earth, there are about 20 separate plates that are always moving around. Land masses are under the ocean. They're kind of moving around. They rub up against each other sideways. They hit each other head on. Sometimes they're subducted or they go underneath one another. And with all this activity, that's when a lot of the earthquakes are occurring. So if you have two pieces of land that are butting up against each other like this, eventually something has got to give, and boom, you have an earthquake. So let's talk about how we measure that, or how we figure out how big an earthquake is. Let's say that this piece of spaghetti is two land masses coming together and hitting one another. And there's so much force and so much force and so much force until boom, something snaps, right? And that's the earthquake. So if this is a magnitude 5 earthquake, let's just say, for example, this is a 5. You saw it didn't take a lot of force from me, but you can imagine if it was a big piece of earth, that would take quite a bit of force to make that force kind of explode like that. So a magnitude 5 earthquake to a magnitude 6 earthquake is not just a little bit more, it's not even double. A magnitude 6 earthquake is 32 times bigger than a magnitude 5. So let's try that again with 32 pieces of spaghetti. So same experiment, you've got two land masses, they're coming together, and when they get together, this is gonna be a lot harder, right? It's gonna take me 32 times the amount of force to break that. And it's spaghetti, so it's pretty easy to break. But you can see that magnitude of an earthquake is it's exponentially bigger the higher you go up on that scale. So let's talk about a seismograph and how we can build one that we can experiment with so that we can understand how they work. So a real seismograph is a complicated thing. It has levers and weights and motors and all kinds of very fine-tuned instruments to help us understand what's happening deep in the earth or a long distance away. This one's going to be just a representation of that. So a couple things you're going to need from home. A piece of paper. I've got a piece of paper here. You can use newspaper, scratch paper, anything you've got that's kind of big enough to do this experiment. You're going to need something heavy. I've got a can of soup. Almost anything like big and heavy would work. Cylindrical is better if you can find that. You're going to need a ruler of some sort, but it has to be flexible, something that can move a little bit. A felt tip pen or a marker, and some tape. And for this part, we're going to need a partner as well if you want to keep going and try the second half of this experiment. So the first thing we're going to do is lay your paper out and get it all ready to go. The second thing you're going to do is you're going to tape the marker to the end of the ruler in such a way that it forms the letter L, right? Like that. So let me go ahead and do that. I'm just going to use some tape. It doesn't have to be perfect. One thing to think about is the second piece of this is to tape the ruler to the can. So you kind of want to make sure that you have enough room on that can when you tape this down, that the tip is going to be able to touch the paper. So I'm going to tape that right about there. It doesn't have to be pretty, it just has to be fairly straight and kind of stable. Okay, so there's my L-shaped ruler and marker. And then I'm going to take the cap off of this thing to make sure we're at the right height. And I guess I'm going to tape it right there. That'll work. So right about there. Just going to make a little hole there. And again, it doesn't have to be perfect. We just want to stay on it long enough so that we can do a little bit of shaking. So, okay, once you have that set up and it's touching the paper, then we're kind of ready to go. We're going to shake the table and pretend that this is an earthquake that's happening. And our seismograph is going to record a series of lines that are going to be bigger depending on how much we shake that table. So the bigger the earthquake, the bigger the amplitude of the lines, or the length between the upper and the lower part of the big wave that's going to be made. The bigger that is, the bigger the earthquake. So let's see what happens. I'm going to move this over here so we can get a sense for this. I'm going to go ahead and shake it. Oh, it's not quite working. So I'm going to raise this just a little bit so it's not pressing so hard on here. I'm going to try it again. There it goes. So you can kind of see that we can record how big that earthquake is by how much that pen is moving on the paper. So a real seismograph has a big roll of paper that's constantly moving all the time, and a pen that stays stationary. So as that paper's moving and that pen is moving, it's making a graph that kind of goes along the page quite a bit. So my assistant, Andy, over here at Nevada County Media, is gonna pull the paper slowly while I shake the table, and we're gonna see if we can do something that's gonna simulate a little bit more closely what an actual seismograph does. So are you ready, Andy?
Ready.
Here we go. Ah, look at that, it's working. A big wave. Nice. All right, so if you can see that, that's a little bit more accurate as to what a real seismograph would record during an earthquake on the page. So go ahead and give it a try. Have fun making your own seismograph. I hope you had fun today, and I will see you next week for another episode of Random Acts of Science.